And you know that's not perfect, but I'll take it. Okay, so y-axis symmetry. Again, so this is like be the line of symmetry here. We just got to make sure this thing kind of goes like that. It's going to look like an M. If this point here, and you should probably do the meatballs so that they do what they're supposed to do. So that meatball ends up there. This one here at 8 should kind of go here. And then after that, it should just kind of follow the same general pattern. So yeah, make sure you include the points that are indicated, but then after that, like, that's pretty good. And you know me and my drawings, like if your drawings are anywhere close to like better than mine, like most of your drawings are better than mine, and I'll take them, it's fine. Oh, even, odd, or neither. Well, I was told I didn't answer that in the first video. If this is if they told me to have origin symmetry, like that's the definition of odd, so that's of course going to happen. If I'm told to have y-axis symmetry, I'm told that yes, it's supposed to be even. Oh, later we'll talk about could a function be both even and odd. Ooh, stay tuned. Okay. X-axis symmetry. Well, if x-axis symmetry, then this, it's like now this is the line of reflection. Oh, that was bad. That's the line of reflection, is the x-axis down here. So that's actually really hard to do with the hardware I have. Anyway, so that would have to come down here. Like that little point has to go there. This looks like kind of like a circle. It looks a little bit kind of taller than a circle, but something like this and something like this. Sorry, that's actually really hard. But this isn't even a function anymore. So no, since it's not a function, then we can't even talk about this, right? So I don't even know if I'd even say that's neither. It's not a function, so don't ask me this question. By the way, these, yes, are functions. We can totally be fine with that. Origin symmetry. Okay, so I got to flip this nasty monster across here. Let me do that point at a time. This is 3, what is that, 4? So it'll back here, down 3, and back here, down 4. I can go ahead and connect that to 0, 0, because 0, 0 will reflect and make 0, 0. That's fine. This point here at 6, negative 2, will go negative 6, positive 2 up that way, and I got to connect to this guy. This one at 8, negative 2 will go negative 8, positive 2, and look like a little horizontal segment. That's good. And then 10, 3, negative 10, negative 3, and do this. Well, yeah, it's a function, and it's odd because you told me to do it that way, so of course it's odd. It's got symmetry with respect to the origin. Okay, a rule. Proving even or odd functions. This is really about the proving. Algebraically, if this is going to be true, on both of these, which is kind of nice, whether you're trying to show if it's even or odd, the first thing you do is you compute f of negative x. You put negative x into the rule. So in other words, go back to these. Think about what would happen on the kind of left side of what we're given. Yeah, I'll just say it that way. So if you think about what's going to happen on the left side, if it's kind of is it going to be a spun around thing, and we'll talk about algebraically what that means, or is it just going to be really the same thing, just kind of headed in a negative direction? All right, so we put in negative x into the original function. If we put in negative x and we get the same y value, remember, because this is really a y value. If we get the same y value we would have gotten anyway, that's an even function. So that's like the one over here. If we put in the negative version of x and we get the same height for all those negative versions that we would have gotten at the positive version of the same number, we get this nice symmetry like a butterfly this way. If we put in the negative version of x and we get the negative version of what the height would have been, that's actually the description of what's happening here. So if I put in the negative version of x, I'm also getting the negative version of y. That's the upside down one as I move this way, which turns out to be the same thing as talking about origin symmetry or an odd function. So the nice part about this whole test, this seems really complicated and hard to remember, but really what's nice about this is you put negative x in to the function, and if it comes out to be the original, then it's even. If it turns out to be the opposite, like the negative of the original, then it's odd. If it's anything else, it's neither, as you might expect. Okay, so let's do these algebraically. So without even graphing, I can tell if this is going to be even or odd, which is kind of a cool thing to be able to do. All right, so I'm going to try to figure out what happens if I put negative x into this function. All right, so just be careful. Negative x to the 4th power, I'm going to write it this way just so when you look at this later, you'll be like, oh yeah, that's what that means. Okay, plus, that's a plus. Oh my gosh. I'm trying to do this as much of this off camera as possible because I realize you're in it for like an hour now. All right, so that's going to happen. And then this would be the same thing as, because what happens if I take negative x and square it? Well, it's the same thing as x squared. And remember, really, I'm not really trying to solve this. I'm not trying to simplify it. I'm just trying to find out, does it turn into the same thing as this, or does it turn into the negative version of this? And well, it turned into the same thing. So since it equals exactly that same thing, we are done. I can say, yes, it's even. Yeah, okay. What happens if I do put negative x into this monster? Well, this is 1 over x, so that's going to become 1 over negative x. And yeah, that's the same thing as negative 1 over x, which is the negative version of, what I started with. So this thing turns out to be odd. And lastly, if I try to do negative x on this thing, I get negative x minus 3 squared, which, is that the same thing as this or not? I don't know. I mean, you could expand this if you really wanted to. This is x squared minus 6x plus 9. This thing, if I really expanded it, would be x squared. Okay, that's great. But then in the middle here, I'd actually have a plus 6x. Is it plus 9? That doesn't seem right. Did I do something wrong there? No, actually, I think that's right, because I think this would be the same thing as negative x plus 3 squared, but then I'm squaring a negative thing, because I think it actually turns out to be this anyway. Anyway, it's not the same thing as that. It's not the negative version of that. Yeah, the negative version of this is kind of tricky. It's not negative x minus 3 squared. It's not that. So this is actually a neither. Okay, now where are we at? Oh, is that the end? Really? I made it all the way to the end? Oh, okay, so this last video was shorter. Okay, great. I'll leave you with this. I'll see you on Wednesday or Thursday, depending on which day you have me.